So, equations of motions. Let's talk about the equations of motions. Well, in the previous video, we actually did discuss about that. Sorry about the delay and everything. I haven't really been uploading a lot. So, S is equal to ut plus half at square. This is one of them. Half at square. Half at square. V is equal to u plus at. U plus 18 and v square minus u square is equal to 2as. Sorry for the bad handwriting. So these were the normal equations of motion. So these are the equations of motion. So in today's video, we're going to be talking about the exact same equations of motions, but in a different case, in a free-falling body. Well, as the name suggests itself, it's just a body which is being thrown from some height edge. Let's say from the roof of a building. This is a building and we are throwing a ball. Let's say we're throwing a ball from this height. Let's say the building height is h, the height of the building is h, and we are throwing the ball from here. Well, before we address and represent the equations of motions in this problem, I just need to discuss something. What is weight? Weight. Well, what is weight and what is mass? What is the difference between these two things? Well, it's simple. Weight varies from planet to planet. Why? Because of gravity. As we all know, the formula for weight is nothing but mg. M represents mass. So mass is basically just when you are taking all of the molecules in a body and you're taking them all together. You're taking the entire mass of all of the particles together. So mass remains the same. But weight is the amount of force being applied on you by gravity. So gravity is not only just 10 newtons or 9.8. Gravity is not just 10. Small g is not just 10, but it's actually weight. So to keep you on this planet, gravity has to apply some force, right? So that force that gravity is applying to attract you to the ground, if you are a person here, the force that gravity is applying to bring you down to the ground instead of letting you fly, sad life, is not g. But if my weight is 10, then it would be 10g. Well, we all know small g's value. Small g's value is nothing but 10. So technically this would then become 100 newtons. So nothing but weight is equal to mg. We have to understand this. So weight is equal to mg and weight is the amount of force being applied on you downwards. So if my mass was 40, my mass is equal to 40, what would my weight be? 400. 400. And something we've got to make sure to tell you guys again is that gravity is equal to 9.8 actually, but for simplification reasons we also take it as 10, only unless in the question it is they have mentioned that we have to take gravity is equal to 9.8, then we take it as 9.8. Otherwise it's just easier to take it as 10. So let's continue. So now we have just dropped this ball. So let's say I am here and I've just dropped this ball. That means when I'm dropping the ball, I'm not exerting any force on it, and without any force, there's no acceleration, because acceleration is equal to F by m. If F is equal to 0, then acceleration is equal to 0. If acceleration is equal to 0, and if acceleration is equal to 0, that means initial velocity is also going to be equal to 0, right? So when the exact case when I'm dropping the ball, initial velocity is going to be equal to 0. Initial velocity is going to be equal to 0. This is pretty important. And the next case what we've got to take is, what will the acceleration be? Well, acceleration is nothing but g. G is nothing but acceleration, right? G is not an actual force. G is just acceleration. The acceleration that the force is being applied. So acceleration, G is nothing but acceleration. That's it. So then what we can say? Acceleration is equal to g, right? Because gravity is acceleration, or the acceleration at which we're being pulled down by is g. Alright, so then finally we've got final velocity. Since our body is going down with so much acceleration, by the time it reaches here there's going to be some value of v, right? So this is also nothing but the maximum. Final velocity is also equal to maximum velocity, because because acceleration will only be there until it hits the ground. After it hits the ground, gravity is done. Gravity's job is done. Then it won't apply any acceleration downwards, because then normal force will also be there, so it would cancel. So when it hits the ground, then final velocity is gone. And next, what we've got to consider is S, our distance. So next, the height is nothing but the distance covered by the body, right? Because this is the distance being applied by it. I mean, the distance it's being covered is from the height and then going down, right? Simple as that. So what we can say is, one second, our distance is equal to height, our initial velocity is equal to 0, our final velocity is equal to v, and our acceleration is equal to g, and time will stay the same. Time, and we take time as time of descent. Why are we taking time of descent? Because nothing but it's going down, right? It's descending, it's going downwards, right? So that's why we take it as time of descent. But that's not important right now. When we talk about vertically thrown bodies, that will come into the concept. Okay? So next, what we've got to do is we've got to substitute them in every single formula. So let's substitute it in the first formula. V is equal to u plus at. Well, this formula very simple. It will become really simple. Sorry about that. V is equal to 0 plus gt. So V is equal to gt. V is equal to gt, first formula. Otherwise, we can also say T is equal to V by G. T is equal to V by G. So T is equal to V by G. We can also say that, but that's not the final velocity. This is the actual formula. First equation of motion. Let's talk about the second equation of motion. S is equal to ut plus half at square. अभी तो मजा शुरू होगा. Is equal to ut plus half at square. S we've got to substitute as h, height. Ut, this will become 0 plus half gt square. Half gt square. Next, what we can say here is we can take 2 and g to the other side, right? So we get 2h by g is equal to t square. So then t is equal to root 2gh. Root 2gh. Root 2 by g. Sorry, root 2h by g. So this is the second equation of motion where we get t. Something also we can do here is that if we wanted to, we could have also substituted v. Then next, what we can do is we can substitute this part, t is equal to v by g. Not really important, but we can then say v by g. V by g is equal to root 2h by root g also. Root g. So next, what we can say is v. Let me actually write this up here. I'll write it up here. So v is equal to root 2h by root 2g. I've written it separately because then you see we've taken g from here and we've taken it here, right, to the RHS side. We can also write normal g as root g into root g, right? We can also write it as root g into root g. So then what we get? We get root 2gh. Root 2gh, right? Because then this g and this g will get cancelled. So we'll get v is equal to root 2gh. And this is so we get two important formulas from here. Root 2h by g and this. So these two are important formulas. We get t is equal to root 2h by g, time of descent. You're going to realize when we substitute the values in the third formula. One second. When we substitute the values in the third formula, v square minus u square is equal to 2as, we're going to get something very similar to what we got before. So v square, we can say v square is equal to 2gh. So actually, we just got the exact same thing from equation 2 and from equation 3. From equation 2 and equation 3. We got the same thing from equation 2 and equation 3. You can see we also got this from equation 2. How did we get this? By substituting this. This is something really fun and interesting that I actually found out just now by doing it. I'll be honest. I didn't know that we could find it from the second equation. I was just doing it for fun before recording this video, and I realized, hey, we can do this as well. So the final formula that we get, v is equal to t by g, if I'm correct, or gt. No, v is equal to gt. Sorry for that. V is equal to gt. T is equal to root 2h by g, root 2h by g, and then we finally get v is equal to root 2g. V is equal to root 2gh.